Okay, now let us have a couple of examples. The first example is that consider your L to be the set of non-negative real numbers, and consider the Borel field. The Borel field is that means that if I said F is Borel field, means that all my events A, any event A is like, this is like time, so 0 to plus infinity. A could be decomposed as union or intersection of intervals. So A has like first interval, second interval, I2, third interval, I3. So A is union of like these three intervals. So if I say Borel field, means that A is equal to union of some intervals, and I could be 3, 4, 5, or it could be 1 to infinity. It should be countable. So in this example, I define probability of A as this guy. This is a Lebesgue integral. This means, this notation A means, first A, because is a Borel field, this means summation over I equal 1 to plus infinity of integral over intervals over II, okay? And this integral itself means summation I equal 1 to plus infinity, and this interval has like AI to BI. So from the interval, because this II itself is an interval, so it's the set of numbers between A1 and A2. Okay, so if you apply this integral, and then the rest of the integral is a Riemannian integral, so this is called Lebesgue integral. So you can easily show that this is a valid probability measure, and then you have a... The reason is that the total integral, if you put this A as L, so probability of L shall be equal to integral, because from 0 to infinity is one integral, so it becomes from 0 to plus infinity of e to the power minus x dx, and then this is equal to 1, so it will satisfy. The second example I want to have is that Poincaré theorem. If you have n events, probability of their union based on property of probability space, we said that if these sets are disjoint, probability of the union is the sum of probabilities. But if they're not, it means that their intersection is counted more than once. So you have to reduce the probability of intersection. For instance, if you have probability of A1 union A2, okay, so this is equal to probability of A1 plus probability of A2, and then you have to deduct probability of A1 intersection A2. Why? Because in these two components, intersection is counted twice. Now, if n is equal to 3, for this case, what you do, this is called Poincaré theorem. So you say that probability of union is probability of the sum, and then then we reduce the intersections 2 by 2 intersections once. But now if you do that, this is like 3a, this is b, and this is c. So you see that if I add this probability, this one, that means that this intersection is not only calculated inside A, is also calculated inside B, and this part is calculated inside B and C, and this part calculated inside A and B. This is why we remove these 2 by 2 ones. Now, what happens is that if you remove that, means that this intersection of all of them is removed 3 times. But also is calculated 3 times. So it means that it is not present. So this is why I add it again. So what happens here is that when you have more than 3, so you have to put plus sign, add them, and then 2 by 2 remove them, and then you put plus sign and add them, and then so on. So this is called Poincaré theorem.